Welcome to today's deep dive. We've been looking through the stack of notes you sent us on the efficiency equation. And, well, our mission today is really to unpack this and discover those actual, boots on the ground tactics, the things that keep industrial facilities running smoothly.
Right, because usually when we think about making machines more efficient, the instinct is just to, mash the gas
Yes,
pedal.
make it go faster. Yeah.
Exactly.
Yeah.
But looking at your sources, efficiency isn't actually about pushing harder.
No, it's about removing the speed bumps. So when plant managers are obsessing over their overall equipment effectiveness, their OEE, how do we practically move the needle?
Well, it means looking at the entire system and locating the friction. I mean, friction is what's actively destroying those numbers. The notes you provided actually highlight a pretty staggering example of this.
Oh, the bearing one.
Yeah, facilities losing literally thousands of production hours just because a single bearing was over-lubricated.
Which sounds completely counterintuitive, right? Like more grease should mean less friction.
It really does sound that way.
Hmm.
But pumping too much grease into a bearing, it actually blows out the seals. It traps the heat inside and churns the grease into a solid.
Oh, wow.
Yeah, which causes the exact catastrophic failure the technician was, trying to prevent in the first place.
Okay, so I get standardizing work orders to prevent that. But telling a 20-year veteran mechanic exactly how many milliliters of grease to use, that feels a bit like micromanagement. Does that actually fly on the factory floor, or do they just kind of ignore the tablet?
I mean, if the system is rigid and unhelpful, yeah, they'll absolutely ignore it. But handing a mechanic a vague work order that just says, grease the motor, that's like handing a surgeon a scalpel and saying, fix the patient.
Right. Good luck with that.
Exactly.
Yeah.
The tool is useless without the exact procedural roadmap. And that's why taking a CMMS approach, a computerized maintenance management system, it fundamentally changes operations.
So they're getting specific instructions instead of just a general task.
Yes. Like when you look at platforms used for Cryoto's maintenance management, you see facilities attaching standard digital procedures to every single task.
Taking the guesswork out entirely.
It does. It specifies the exact lubricant type, the precise volume, and even the required ultrasonic tools. It turns all that manual guesswork into, well, a mathematical certainty.
Okay, so locking in the exact grease volume solves the human error piece. But even if we perfectly execute the maintenance, machines still wear down unpredictably, right?
They do, yeah.
So how do we catch the friction that those standard routines miss? Because humans can't be watching 24/7.
Well, this brings us to the IoT acoustic sensors that were mentioned in your research. This technology completely shifts the entire model from preventative to predictive.
Oh, because these sensors literally listen for high-frequency friction. Like, if a bearing is just starting to run dry, it creates a sound wave we can't even hear.
Right, but the sensor catches it.
Yeah, and then it automatically triggers a work order before a human operator even feels a vibration on the machine, which is just wild to think about.
It is wild, but catching that inefficiency before it registers physically, that is the ultimate goal here.
So for someone listening who wants to apply this to their own operations, where do they even start?
The primary rule to take away from the sources is consistency before efficiency. You simply cannot speed up a chaotic process.
Makes sense.
So your practical first step is to pick your top 5 most frequent preventative tasks. You document the exact standard operating procedures for those, and you lock them into a digital platform to ensure identical execution every single time.
Basically, pave over the speed bumps before you hit the gas pedal.
Exactly that.
Which really leaves us with a rather fascinating concept to ponder based on the notes you shared today. If we are entering an era where machines can, hear their own internal friction and then automatically order their own digital repairs, well, how long until human operators become mere assistants to the equipment they supposedly run? Don't forget to subscribe to the Cryoto's Maintenance Management Podcast.